Just need 1 second to start uploading this. Oh, I got scared. I said I thought I didn't record, but it's there. It's there. Okay, next one. Number 16. Let's read it together. A spotlight on the ground shines on the wall 12 meters away. Okay, that's my first sentence. I'm going to present the wall. I'm going to show the 12 meters, and here is the light, or whatever that is, the spotlight or flashlight or whatever. If a man 2 meters tall walks from the spotlight towards the building at a speed of 1.6 meters per second. Okay. Sorry, I can't draw a man. Okay. So he's 2 meters tall. Okay. So he walks this way towards the wall. At a speed, so this is the distance that he covers. I'm going to call it x. And please tell me, what is 1.6 meters per second?
dx.
Very good. Good. Now I can read on. How fast is the length of his shadow on the building decreasing? How fast is the length of his shadow on the building decreasing when, and I shouldn't even read the words after when, because I don't want you to think that we have to use that. When he is 4 meters from the building. I don't care. I will always stop at the word when. The rest has to wait. It cannot come into play at all till the very last step in which I plug in whatever. Okay. So here's what happens. This is the shadow on the wall. We're going to call it Y. As he gets closer and closer to the wall, here he is again. Okay, here's what happens. This will become the shadow on the building or the wall. So obviously dy over dt is what we are asked to find. And I will make myself a note. Will it be a positive rate or a negative rate? Yes, it must be negative. Now also, I'm asked to evaluate this function when I get it, decreasing when he is 4 meters from the building. What does 4 meters from the building mean? In other words, when x is, that's it. So let's analyze the whole thing one more time from scratch and then decide what to do. Okay. So there is a flashlight here, and it's pointing towards the building. Spotlight, you know, you see some buildings have something like that. A man is walking from the spotlight towards the wall or towards the building. His height is 2. He covers this distance, starting from here and getting closer and closer to, so this distance is increasing. Because so it's a positive rate because the distance is increasing as he gets closer and closer to the wall. We are given that rate of change. He's walking at 1.6 meters per second. We are asked to determine how fast is the shadow on the building changing or decreasing at a particular instant. But that instant is not of our concern at this point. What is the instant? When x is 8. But if I don't have the function, I can use the instant. So obviously, I have to create a relationship between what? Definitely, I see two variables. I see exactly. That's all I have. So somehow I have to come up with a relationship that connects these two. So let's see how we do that. Let's take a look. And here are my hints. And here's one more little hint for you. What am I telling you? I'm telling you that there is a little triangle, small triangle, and there is a big triangle. And what is the concept here? If I manage to show it, I have to explain, but what is the idea? What am I thinking of? You just came in. Oh, I'm sorry. Thank you, Nick. Indeed, similar triangles. But I have to show why. I cannot just say, hey, these are similar, let's move on. No, I have to show at least two pairs, because the third one will be the same. Two pairs of, we say equal, but we prefer congruent angles. And then I can conclude that the small triangle is similar, that's the notation for similar, to the big triangle. Okay. Is this angle present in both? Yeah. So it must be the same, right? Is the right angle present in both? Yes. So can I immediately conclude that these two must be the same? There is no other way because they add up to 180. So this is a common angle. These are two right angles. Therefore, these two must be the same. Showing that, now I am allowed to write proportions with the sides of the triangles. But you have to be very careful. The order is very important. So let's start with the common angle. What is the opposite side of the common angle in the small triangle? I will have small at the top and big at the bottom. So what is the opposite side, opposite to the common angle in the small triangle? 2. Excellent. What is for the same angle? What is the opposite side but in the big triangle? If I move on to the right angle, I know nothing about this and I know nothing about this. So this is not useful. I'm moving on to the upper angles. I have to come back to the small triangle first. What is the opposite of the common angle, third pair, in the small triangle? X. And what is the opposite of the other, of the equal congruent angle in the big triangle? Cross multiply, because this is a proportion, x times y equals 24. That's all we need in order to find what? Again, what are we after? We are after dy over dt, indeed. Okay, so let's differentiate. Remembering that x and y are functions of t. So, the left-hand side, let's differentiate, please. Remember something very important. Careful. So the first function prime, dx over dt times the second function, plus x times over dt equals how fast is 24 changing at any point in time? Good. So on the second problem, we did not write something that we wrote on the first one. Maybe it's useful to write it. So I'm going to write it here. X is a function of time. Y is a different function of time. So we don't forget that when we differentiate, these are two functions. And they're functions of time. Does it make sense? Very good. So coming back, we are after this. I will move everything to the other side and divide by x. So it will be negative. So dy over dt will be negative y over x times dx over dt. And now I can say, fine, when x equals 8 meters. Eight meters. Any questions so far? Everything okay? So I know that this is 8. I know that this is given to us. How much? Perfect. How do I determine y? From here, from this relationship. Knowing that x is 8. Yes, so when x is 8 meters, obviously y is 3 meters. When x is 8, y must be 3. So then this is 3. So as expected, we get a negative answer. So negative 3 divided by 8 times 1.6. I'm sorry, it's 1.6 at the top. See, I wrote it down here. Wrong. I should have put it at the upper right so I don't make this mistake. Okay, how much is this? We have a number. So 3 times 1.6 divided by 8. I should have not done that because it's 0.6, right? So negative 0.6. Without measurement unit, we cannot accept it. Very good. Was 1.6, yes, meters per second. Any questions? In this problem, we had two related rates. The rate of change of distance with respect to time as the person was approaching the wall, and the rate of change of his shadow on the wall. Two related rates. Okay, let's take a look at 27. Gravel is being dumped from a conveyor belt at the rate of 30 cubic feet per minute. So 27, 30 cubic feet per minute. I have to identify what this is before I read on. What would it be? The measurement unit tells us exactly what it is. That's why this is so helpful. What do we measure in cubic feet? That's it. What do we measure in minutes? The measurement unit tells us what it is. It's the rate of change of volume with respect to time. Agreed? Very good. Let's read on. And it forms a pile in the shape of a cone. Here it is. The pile in form of a shape of a cone, whose base diameter and height are always equal. How fast is the height of the pile increasing when the pile is 10 feet high? So this is the cone. This is the height. Since the height and the diameter are always the same, I'm going to use the same notation. And I'm going to read the problem one more time and realize what we need to do. Gravel is being dumped from a conveyor belt at 30 cubic feet per minute. It forms a cone where the base diameter and the height are always the same. How fast is the height of the pile increasing? When, and remember the rest is not for now, when the pile is 10 feet high. So what are we asked to determine?
DH, DT.
Thank you. When the height is 10 feet.
H equals 10.
Remember, this is not for now, not to be taken into account till the very last step. So I have to write myself a couple of notes, if that helps. V is a function of time. H is a different function of time, and there is nothing else. In this problem, again, we have only two related rates. The rate of change of volume with respect to time and the rate of change of height with respect to time. Where is my starting point? Obviously, I have to create something that connects these two somehow. Because if I can't find an equation that creates these two, I can't determine anything.
The volume of the cone.
Yes. So let me remind you how to remember if you want a volume of a cone. It's 1/3 of the volume of a cylinder. So here's a cylinder. It's a cylinder. The volume of a cylinder is area of the base, which is pi r squared, times the height. Pi r squared times the height. So the volume of the cone will be 1/3 pi r squared times the height. And you can say, wait a minute, we are in trouble. Not really.
R and H.
Exactly, exactly. However,
So
H is 2r. So since H is 2r, I have to solve for r, which is H over 2. So this piece will be replaced by H squared over 4. Okay? So this will replace this because we know nothing about the radius. We don't even want to know. Two related rates are good enough. So then, one more time, V equals 1/3 pi H squared over 4 times H, which is pi over 12 H cubed. Do we agree with pi over 12 H cubed? I replaced r by H over 2, and when I squared r, I got H squared over 4. So 1/3 and pi, and this gets replaced by H squared over 4 and times H. So pi and 12 and H squared times H is H cubed. Now I'm going to write it one more time because I'm getting it ready to do what? Implicitly. Although you could say, well, remember we wrote ourselves a note here. So then, the left-hand side,
dv over dt.
of course. The right-hand side is pi over 12 times,
3/8 squared.
yes. Is this okay, everyone? What are we after? That's why I need to write myself a note. I'm after d over h over dt. I have to solve for the h over dt first. Yes. So dv over dt. So I'll simplify. So I get pi h squared over 4. The h over dt. And then I will multiply by what to eliminate all this? I want to get rid of this. What should I multiply both sides by? 4, exactly. 4 over pi h squared. So 4 over pi h squared times dv over dt equals dh over dt. One more time, dh over dt when h equals 10 feet is 4 over pi times 100 times dv over dt, which was given to us from the very beginning, which is 30. I put all this in the calculator. It's 120 divided by pi and further divided by 100. And I got, correct me if I'm wrong, 0.382. 0.382. Without measurement unit, it means nothing. What is the measurement unit on this?
Feet per minute.
Perfect. Indeed. Feet per minute. Any questions? This problem had two related rates, volume and height. Say it again.
Where'd you get 30 from?
This was given in the problem.
Oh.
Any questions? 29. Any questions? Anyone? Any questions? Yes.
So for pi h squared before,
Yes.
why did that? How did you get 4 over pi h squared?
Okay.
Why it flipped?
So when I multiply these two, I get 1. When I multiply these two, I get 1. That's why we multiply by the multiplicative inverse of this. But if I multiply on this side, I have to multiply on that side. So that's how we get the 4 over pi h squared here, but it disappears from here because this is 1. Because we were trying to solve for this variable. Better? Okay, 29. Let's read it. Two sides of a triangle are 4 meters and 5 meters in length. And the angle between them is increasing at a rate of 0.06 radians per second. Okay, I'll stop. I'll show a triangle in which this is 4 and this is 5 meters. And I'm going to call this angle theta. Two sides of a triangle are 4 and 5 meters in length, and the angle between them is increasing at a rate of 0.06 radians per second. What does this mean? What is given in this problem so far? Say it again.
I mean, dr.
We called it theta. So it's d theta over dt. Indeed. Very good. Find the rate at which the area of the triangle is increasing when, and I don't care for that when, but I'm going to read it, when the angle between the sides of fixed length is pi over 3. One more time, let's read the problem one more time from the beginning. Two sides of a triangle are 4 and 5 meters respectively in length, and the angle between them is increasing at a rate of 0.06 radians per second. Find the rate at which the area of the triangle is increasing when the angle between the sides of fixed length is pi over 3.
The remaining side.
Okay.
Let's read the problem. I think it's not very clear to all. Very good. Thank you, Nick. Two sides of a triangle are 4 and 5 in length, and the angle between them is increasing at a certain rate. Find the rate at which the area of the triangle is increasing when the angle blah, blah, blah. Good. I'm ready. Now, you may remember this from pre-calculus or not. There are 3 different ways of determining the area of a triangle. One of them is what we know, base times height divided by 2. But that's not the case here. The second one is, the area of a triangle is A times B times sine C divided by 2, where A and B are the given sides, and C is this angle in between. If C is given here, and these two sides, we cannot use this formula. If C is this, and we're given these two sides, we cannot use this formula. So the requirement is 2 sides and the angle in between. Then we can use this form of the area of a triangle. So, obviously there are 2 related rates here. Which 2? Which 2 functions are we talking about? And they are both functions of time.
DADT.
Very good. So area is a function of time, and
Angle.
theta is a function of time, a different function of time. So we have 2 related rates. The area, the rate of change of the area with respect to time, and the rate of change of the angle with respect to time. Good. So we are going to start by writing the area, which is A equals 4 times 5 times sine theta divided by 2. And of course I will simplify, because 4 times 5 is 20 divided by 2 is 10. So the area equals 10 sine theta. Say it again. 4 times 5 is 20. That's okay. That's okay. So what are we going to do next? Implicit differentiation. Or just differentiate both sides. Very good. So,
DADT equals 10 times cosine theta times
right? Because it's cosine of a function, so it's sine of a function prime, which is cosine of the function times the function prime. And the problem is done almost. All I have to do is just plug in pi over 3, in which this is given to us as 0.06, and I just have to determine cosine pi over 3. So let me refresh your memory on that little chart with sine and cosine. So theta, sine, cosine, and this is the small angle pi over 6, the middle angle pi over 4, and the big angle pi over 3. So here's what I would recommend. This is what I do with my pre-calculus class. This is the easiest to remember. Sine of pi over 6. Well, this is also 1/2. Cosine pi over 6 is the square root of 3 over 2, which is here. And these two are always the same. This is the only angle for which sine and cosine are the same. So since it's cosine pi over 3, so this is cosine pi over 3 is 1/2. So this is 1/2. So 10 divided by 2 is 5, and 5 times 0.06 is 0.30. Measurement unit.
Radians per second.
Say it again.
Radians.
Careful.
Square.
Careful. We look here. So it has to be two measurement units, right? One coming from the top and one coming from the bottom.
Feet squared per second.
Yes. Square feet per second or feet squared per second. Very good. Any questions? So let's summarize what this was all about. Two related rates. One, the angle that was changing, that was triggering a change in the area. So once I increase or decrease this angle, of course the area increases or decreases. So they were related, and we determined, first of all, we have to remember this formula, in which if we are given two sides of a triangle and the angle in between, we can determine the area. We can find the area. That's the second one. The third one is the Heron's formula. So with the semi-perimeter. Those three formulas for finding the area of a triangle. But in that case, we need all three sides. Okay, let's move on. Yes, so let's take a look at number 10 on page 248. A particle is moving along a hyperbola xy equals 8. As it reaches the point 4, 2, I put myself a big note. The y-coordinate is decreasing at a rate of 3 centimeters per second. The y-coordinate is decreasing at a rate of 3 centimeters per second. What is this? And what is its sign? Oh, sorry. Questions.
Which is the 3 centimeters per second?
Yes. So let's read it again. A particle is moving along a hyperbola, which is xy equals 8. As it reaches the point 4, 2, I make myself do not dare to put that anywhere. The y-coordinate is decreasing at a rate of 3 centimeters per second. If it's decreasing, what is the sign? Very good. And what does it mean?
dy dt.
Thank you. Perfect. We read on. How fast is the x-coordinate of the point changing at that instant? So what are we asked to determine? dx dt when x is 4 centimeters and when y is 2 centimeters. Very good. So the particle is moving along this hyperbola. We know that dy over dt is given to us. We're asked to find dx over dt, specifically when x is 4 and y is 2. But I can't use that before I find the function that represents dx over dt. How do I do that? I make myself another note. X is a function of t. Y is another function of t, so I don't mess up the differentiation process. So I differentiate the left and I differentiate the right. So what do I have on the left-hand side?
X
over dt times
Plus
plus x
times
dy over dt equals
0.
0. We had something very similar, if you remember, with that person moving. Okay. So we are after this time, we are after dx over dt. I will subtract and divide by y. So dx over dt will be negative x over y dy over dt. Now we're ready to plug in the numbers for x equals 4 and y equals 2. This was given to us as negative 3, yes, centimeter, and we are given x, which is 4, and y, which is 2. 4 divided by 2 is 2. 2 times negative 3 is negative 6, but times a minus in front is positive 6. Measurement unit.
70%.
Very good. The measurement unit is always coming from the measurement unit for the top divided by the measurement unit for the bottom. How are we feeling so far? Not too bad. Not too bad, right? Once we have a relationship that involves these related rates, then from that point on is not that hard. So maybe the most difficult part is to come up with a relationship. Okay, so let's practice some more. Okay, I'm also looking at the very end of the chapter at the review, see if there is anything interesting in there. Yes, 97. On page 267. Let's read it together. The volume of a cube is increasing at a rate of 10 cubic centimeters per minute. How fast is the surface area increasing? When, and I should not read that till the very end, when the length of an edge is 30 centimeters. So the volume of the cube is increasing at a rate of 10 cubic centimeters per minute. What does this mean?
TV over DT.
Good. So here's a cube. So x, 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 x. How fast is the surface area increasing when the length of one edge is 30?
That's D of, call it S
Perfect.
over DT.
Good. So now I have two notes for myself. V is a function of t. S is another function of t. Not to forget how to differentiate. Now the next step would be to identify the surface formula. So how many sides does a cube have?
6.
Okay. And what is the surface area of one?
30 or X squared.
Very good. So this is 6x squared. This is the surface area of a cube. The surface area of 1 is x squared. Multiplied by 6, they're all equal. So I found a relationship between S, not yet, sorry. So now I have to, this is what I'm interested in, but I have to connect actually, not this, not x, but I have to connect the surface and the, yes, the surface area and the volume. So let's go back to the volume for a moment. So what is the volume of a cube?
Both sides cubed.
Yes, exactly, x cubed. So now, because the problem is only relating us the volume and the surface, I have to get rid of x. So let's say x squared equals s divided by 6. X is a positive number. Everything is a positive number. So when I take the square root, I will not write plus or minus. And I will plug this in here. So V equals square root of S divided by 6, everything raised to the third power. Better, V equals S to which power over 6 to which power? Yes, or 3 over 2, correct. 3 over 2 and 3 over 2. This is just a number. So V equals 1 over 6 raised to 3 over 2 means nothing. Now we're ready to differentiate both sides. You understand I could have not used X, although X is also changing. I don't have the X over dt. There is no information about the X over dt. So that's why I'm given dv over dt, and if I can connect these two and nothing else, then I'm in business, because that's all I have. I don't know anything about the X over dt, although X is also a function. Okay, so the left-hand side will be, obviously, v over dt. The right-hand side is 1 over 6 raised to 3 halves multiplied by 3 halves indeed, times s to 3 halves minus 1, which is, no, 3 over 2 minus 2 over 2, times I need to solve for ds over dt, and then I will determine the surface area when x is 30. So I'll simplify this a little bit into 3 over 2, 6 to 3 halves, multiplied by the square root of s, ds over dt, and this is dv over dt, and I will divide by this. Or if you want, I will multiply by 2 times 6 to 3 halves, this is multiplied, divided by 3, the square root of s. So then ds over dt is 2 times 6 to 3 halves over 3, the square root of s, times dv over dt. And now I will say when x is 30. So this was 3, the square root of s of 2 times 6 to 3 halves. I had to flip that. So it goes to the numerator, 2 times 6 to 3 halves over 3 times the square root of s. But I do have to find s, which was 6 times x squared, and just plug in 30. So then finally I have 2 times 6 to 3 halves over 3 times the square root of 6 times 900, and multiplied by dv over dt, which was given 10. Do not waste your time. Put everything in the calculator. Parentheses around the numerator with 20 times 6 to 3 halves. So 20 parentheses 20 times 6 caret in parentheses 3 halves. Close the parenthesis for the top and divide by, in parentheses, 3, the square root, in parentheses, 6 times 900, close the parenthesis, and close the parenthesis for the outside. Okay, 1.33. So what does this mean? Say it again.
What about the dVdt? What did you multiply that by 10?
So I had 2 times 10. That's why I put 20.
Oh, okay, I see.
Times 6 to 3/2. Now I'd rather check. Divided by 3, and the square of 6 times 900.
When you put it in the calculator, I just didn't see the
Yeah, I'm
10.
sorry.
So
Yeah, I
didn't see
put
that you
directly
mixed it.
20.
Okay.
You're right. I put directly 20. Measurement unit. And remember, the measurement unit comes from here.
Centimeter squared.
Exactly. Centimeter squared per minute. Any questions? Any questions? Okay, we have time for one more, and then we'll stop. An easy one. Number 5. So what we learned from this problem is that we had 2 related rates, but we had to get rid of x. There were 3 actually, but we did not have any information about dx over dt, so we had to manipulate algebraically to have an equation only depending on v and s, so we don't have to encounter a problem, because we did not know dx over dt. And we knew that when the volume of a cube increases, then the surface area increases as well as the side, the edge, right? Okay, number 5, an easy problem. A cylindrical tank with a radius of 5. So this is given, this is not when such and such. So this is given and it's fixed. Is being filled with water at a rate of 3 meters cubed per minute. What does this mean? What is given here?
dVdt.
Very good. Okay. How fast is the height of the water increasing?
Is that centimeters cubed or meters cubed?
Meters, I changed it, I'm so sorry. How fast is the height of the water increasing? So what are we asked to determine? So dH over dt. Good. So the volume of a cylinder is pi r squared h. The radius is given to us, so v equals 25 pi h. We differentiate, knowing that v is a function of time, h is another function of time. So the left-hand side would be
dVdt.
the right-hand side would be 25 pi times all we have to do is divide by both sides by 25 pi. So dH over dt equals 1 over 25 pi times dV over dt. This was a linear equation, that's why they didn't say when such and such. So it doesn't matter. This is a constant. So 1 over 25 pi multiplied by dV over dt, which is 3. So that would always be the same. So 3 divided by 25 and further divided by pi. So it's 0.0382, approximately 0.0382, measurement unit.
Meters per minute.
Very good. Indeed, meters per minute.